So, a 2-minute introduction to what we do. I tend to find half the room have never heard of heat pumps and the other half have heard that they don't work. So that's a pretty challenging audience usually. I'm going to start off with the word smart, and it means different things to different people. I was never described smart at school or a smart dresser, but smart in this context probably means using available technology. It wouldn't be very smart to pin our hopes on a unicorn dancing over a hill. It probably means an easily harvested resource, so drilling big holes in the ground that might take £2 million and you might not get what you want. Bit of a challenge. Make it local, don't import it from overseas. Quickly controllable would be a smart idea. Mug to utility, heating and cooling. Clean air would be a smart thing to do. Coming up with district heating and polluting the air wouldn't be smart. You can kind of see where I'm going. Also making it scalable. There's no point doing something and then finding out you can't actually repeat this job too many times around the country. And lastly, that part again, repeatable. So it's got to be something you can do in lots of places at enough scale. So here's one we did earlier, as they said in Blue Peter, when I was a kid. And this was about 8 years ago. We installed it. It was commissioned to us about 10 years ago. And it's a story of something that's been done. And most importantly, they will still be using this in 2050. It is already, by any definition of future-proof, 2050 ready. So I'd say that was pretty smart. And I'll tell you at the end of what we're doing in the UK. So, town of Drammen, not the most pretty place when they started doing this. They've spent a lot of money. This is a district heated bridge across the river. They've got all sorts of fancy buildings going in, and this is one of the most recent ones, 8 years ago. It's still the largest 90-degree heat pump in the world. Keep that in mind. And so what does it do? Well, it's just a big fridge. It's got the cold bit and the warm bit. You put some electricity in and you move heat from the thing that you're cooling down to the thing you're warming up. It's a little bit more complicated, obviously, on a large scale. So we've got lots and lots of different heat exchangers. It's still the cold bit moving heat to the warm bit. Don't ever describe it as refrigeration in reverse. The energy still is moving uphill. And so we've then got lots of different heat exchangers, and there's 3 systems put into one. And the upshot is they're getting over 13 megawatts. That's enough for about 13,000 individual houses if they were all taking heat at the same time. And it's in a district heating network of a fairly large size. It's 28 megawatts. And the smart thing for them is 85% of their heat comes from the heat pump and only 15% comes from gas. So where else have we done this? Well, there's a couple in Norway, there's one in Switzerland, there's one in Belgium, the one in the south of France. We've done a few in London, so the Tate Modern is an example of a river source heat pump. We're now also building one in Scotland at Queen's Quay with Vital Energy. And this is really where I came to, and I'll sit down after this. How does a heat pump work isn't about the technology of it, it's about the commercial opportunity. How do you get enough of a heat source, enough customers that want to tie into that, equipment that can do it, and the end user vision, and tie it all together as a return on investment? That is what makes heat pumps work, and that is what is going to deliver us clean heat for 2050. Thank you.